stack heater. We can't do it any other way because the emissions are minimal. But effectively, they're again working in the same way, getting that warm air circulating down. 2003, I thought I would just emphasise the importance of the inversion layer. 5th of October, it's interesting, I was driving up from Christchurch to the south and I phoned the vineyard managers and said, we're going to have a problem tonight, guys. We'd had this strong wind, it dropped a lot of snow, the temperature had dropped from 14 degrees centigrade down to about 3 degrees centigrade by 3 o'clock. Okay, the dew point was -1, and we were predicting a -3 degrees centigrade overnight temperature. This is what happened. Temperature dropped down to here, hit the dew point and went on down, and that went down to -3 or thereabouts. The red line here is a temperature logger, and they're really valuable things to have. They cost a couple $100 and worth putting into your vineyards. But you can see what happened. The red line here was a logger that was close to the wind machine. The other two lines were further away. You can see that when the wind machine was turned on, the temperature lifted by about 2 degrees. Unfortunately, the lack of a inversion layer meant that that warm air was very quickly used up, and within a couple of hours the temperature next to the wind machine had returned to that of the main area, and the minimum temperatures that were achieved were similar. The wind machine hadn't done any good at all. I won't worry about those. So knowing something about the strength of the inversion layer is very important. If you've got no inversion layer, you might as well go and buy your bottle of whiskey.
Also, the whiskey's sounding good.
So we're allowed to use return stack heaters. They are actually quite effective, particularly when used in conjunction with wind machines. A small number around the wind machine creates more turbulence and is much more effective. If you're just going to rely on them, you need quite a lot of them to operate in a vineyard. Things about windmills and helicopters, there are resource management issues. There are quite strict controls as to where you can put these things in relation to neighbours, and as I say, we're all sitting waiting for a helicopter to run into another helicopter at 3 o'clock in the morning in the dark, particularly when you've got 110. We had one hit a power pole last year. Water. This is really the only other alternative we have. Water works in a completely different process. It's relying on the heat generated as water freezes. Okay? And so you have to be able to continuously apply water to the plant part. There are two alternatives in terms of water. One is a sort of solid set sprinkler system that covers the whole vineyard area. And another alternative are these things here. They're called flippers. You've possibly seen them. They deposit water just along the row. The advantage of these is that potentially they use a lot less water than a full system. Now, to apply water, you're probably going to need about 1 millimetre applied per degree centigrade of temperature that you're trying to protect. So if you're going to get down to -4 frost, you need 4 millimetres an hour minimum for the duration of the event until the heat of the morning sun starts to melt the ice. That's a lot of water. Putting them in the right place. Unfortunately, a lot of our vineyards are using 7.2 metre post spacings. Now, a lot of these sprinklers, these flippers, were designed to operate off 6 metre centres. What happens? You get non-uniform water distribution along the row. People increase the operating pressure of the system to make sure that they get spread. Doesn't improve the uniformity a heck of a lot, but what it does is it reduces the droplet size. Then the droplets are more vulnerable to wind drift. And I've seen vineyards where the middle of the row has been beautifully protected, but the row itself has basically been not protected because the wind has literally blown the water from the sprinklers into the inter-row area. There's nothing more upsetting than having a very expensive frost protection system that doesn't work. As I say, turning the water on, making sure that you're applying the water at an adequate rate is important. It's not the ice that's protecting the buds, it's the heat that is generated as a result of the water freezing. Startup temperatures. In the case of water, if you're using a water control system, you mustn't start up too early. Here, the startup of the water was at 0.5 of a degree centigrade. And you can see that the purple line here is the one that we want to be looking at. The temperature drops to well below freezing. Now, why has that happened? It's happened because the water has washed away all of the ice nucleation sites before it started to freeze. So it's supercooled, and then suddenly it froze at -1.5, by which time damage had been done. By delaying the startup time till the temperature had dropped to 0.5 meant that when the water hit the plant, this is a non-damaging temperature, it meant that when the water hit the plant it froze, and then we started to get heat released. And you can see that the temperature here remained close to zero. All to do with startup temperature. So knowing how the system works, knowing the uniformity and the distribution, knowing the temperatures at which you start the systems up is really important. Don't just turn the water on and walk away. And talking about turning on and walking away, it doesn't matter what system you use, you need to be out there. You're probably out there anyway unless you're just drinking a bottle of whiskey. But there's nothing worse than having the system fail. You know, the fan doesn't fire up. It might have an automatic start on it, but if it doesn't fire up, it ain't going to do any good. Sprinklers, a classic problem that you have, particularly with these micro sprinkler type systems, is water freezing in these pipes. So you need to be there making sure that they're operating, and I would suggest you take your umbrella with you. So water sprinklers, you need lots of water. The application rate depends on the severity of the frost, and again, one of the disadvantages with water is that it doesn't matter what sort of temperature you're going to go down to, you start to apply water at 5 or 6 millimeters an hour, even if the temperature has only dropped to -1. They work okay in the spring. There will be problems with using them in the autumn. But they do work in advective situations where you've got no inversion layer. There are other alternatives. I've done some work using anti-transpirants, and they work absolutely brilliantly. Every time I went out and sprayed my anti-transpirant, we didn't get a frost. All right? The problem with looking at these sorts of processes, anti-transpirants, copper sprays, and Tom's going to talk about ice nucleating bacteria in a moment, is they will only work under certain circumstances. That critical temperature